Hi everyone, I am Adriana A. Fernandez, and today I'll be walking you through our microprocessors addressing modes assessment. So, first, exercise 1, let's identify the addressing modes used in each instruction. Number 1, move the contents of the BX register into the AX register. So, as you can see here, they are both operands are registers, so it is register addressing mode. Number 2, move the value stored at memory location 1234H into AX register. The address is specified directly, so then it is direct addressing mode. Number 3, move the value from the memory location pointed to by the SI register into the AL register. The address is indirectly specified by the SI register. Therefore, it is register indirect addressing mode. Next, we have the number 4. Move the value in the AX register to the memory location calculated by adding the contents of the BP and DI registers. The address is formed by a register, which is the BP, and an index register, which is the DI. So it is based index addressing mode. Number 5, move the value from the memory location calculated by adding the contents of the BX and SI registers and the displacement, which is the 08H, into the CX register. The address is formed by a base register, which is the BX, and an index register, which is the SI, and a displacement, as I'd mentioned, which is the 08H. Then it is base index with displacement mode. Next, number 6, move the value in the AX register to the memory location pointed to by the DI register. The address is indirectly specified by the DI register, therefore it is registered indirect addressing mode. Number 7, move the value from the memory location calculated by subtracting 10H from the contents of the BP register into the AX register. So the address is formed by a register, which is the BP, and with displacement. So my answer is based addressing mode. Number 8, move the immediate value 5678H directly into the AX register. The operand is a constant value, so it is immediate addressing mode. And lastly, we have the number 9. Move the value from the memory location pointed to by BX register into the AX register. The address is indirectly specified by the BX register. Therefore, my answer is register indirect addressing mode. So, next we have the exercise 2. Here, let's write 8 8086 or the 8086 assembly code snippets to demonstrate different addressing modes. So number 1, immediate addressing. Store this value into AX register. So this is my code. We need to move this value into AX. So this is our destination, which is the AX, and the value that we need to move. So the value 0x55A is directly loaded into the AX register. Next, we have the register addressing. We just need to copy the contents of BX into AX. So technically, we just need to, this code, move that BX to AX. Next is direct addressing. Move the value stored at memory location 1234H, this constant value, into AX. So again, move this 1234H into AX. The value at memory location 1234H is moved into AX register. Next is the register indirect addressing. Assess the memory location pointed to by SI and store it in the destination mentioned, which is the AX. So the value at the memory location pointed to by the SI register is moved into the AX register. Next, we have the index addressing. Retrieve a value from the memory address pointed by the sum of DI and a displacement of 10H, and store it in destination, which is the AL. So Again, this is our code. Move this DI plus 10H to AL. The value of the memory location calculated by DI plus 10H is moved into the AL register. Lastly, we have the based index addressing. Here we need to assess memory use using the sum of BX and SI and move it to the value into AX. So the value of the memory location calculated by BX plus SI is moved into the AX register. Okay, now for exercise 3, let's compute the physical addresses given for given instructions. So number 1, compute the physical address for the instruction move AX. This constant value of 1000H in using direct addressing mode. So we use formula here, and that formula is physical address is equals to open and close parenthesis segment address times 16 plus the base address. So we apply that formula to get this final answer using the addressing mode, the direct addressing mode. So segment address is multiplied by 16 and added to the base address to get the physical address using the given using the formula that we used. So now we can move on to our next number, which is the compute the physical address for move AX. Inside the bracket is the BX plus SI plus 10H with BX as 1234H and SI as 4321H. So we use here two formula to solve this problem. So that formula are effective address is equals to BX plus SI plus the displacement, and after that, after we finish that formula, we can now provide or proceed to physical address is equals to segment, open and close parenthesis, segment address times 16 plus the computed effective address. So for our solution, first we need to find the effective address where is equals to 1234H plus the 4321H plus the plus our displacement 0010H is equals to 5565H or the 5565H. So after we done finding the effective address, we can now move on to the physical address. So physical address equals to segment address times 16 plus effective address, the computed effective address. So that physical address is equals to 2000H 16 plus the computed effective address is equals to 25,565H. So to further explain this, how we get this final answer, the effective address is calculated by adding BXX, SI, and the displacement. Then the segment address is multiplied by 16 and added to the effective address to get the physical address. So yeah, now we can move on to our exercise 4. Here, let's analyze now the following code snippet and identify the addressing modes used. So this is the given code snippet. So first, move the value from the memory location pointed to by the SI register into the AX register. So my answer is register indirect addressing mode because the address is indirectly specified by the SI register. Next, move the immediate value 2000H into the SI register. My answer is immediate addressing mode because the immediate value of 2000H is loaded directly into the SI register. So the hint here is having the immediate value, which is the 2000H. Next is the add the value from the memory location calculated by SI plus 10H to the AX register. So my answer is base index with displacement mode because the address is calculated by adding the SI and 10H. Lastly, we have the move the value in the AX register to memory location pointed to by the DI register. Therefore, my answer is register indirect addressing mode because the address is indirectly specified by the DI register. So, we can move on to our number 2. Let me first read the question. If the value of memory location 2000H is 1234H and at 2000H plus 10H is 5678, what will be the final value of AX? Here, let's break down each step to understand how we arrived at the final value of AX. First, the value of memory location 2000H is moved into AX. So as a result, AX is equals to 1234H. Next, the immediate value of 2000H is loaded into SI. So the SI is now set to 2000H and there's no change at our AX at all. So followed by the value at memory location where 2010H is from 2000H plus 10H is now added to AX, and as a result, AX is equals to 1234H plus 5678H is equals to 68ACH. So after that, we need to store this value that we have got. So lastly, the value of value in AX is stored at the memory location pointed to by DI. So therefore, the value of 68AH is stored at the memory location pointed to by DI. So finally, and lastly, the exercise 5, let's write a small assembly program to load, retrieve, and copy and store values using different addressing modes. So first, number 1, load this value into the memory location 3000H. So this is our code here. So the value given 0xabcd is loaded into AX and then stored at memory location 3000H. Next, number 2, retrieve this value using direct addressing mode and store it in AX. So direct using this given 3000H and loaded to AX. So move this 3000, the value memory location 3000H is moved into AX register. Number 3, copy the value from AX to BX using register addressing mode. So simply by the use of this, the value in AX is being copied to BX. So next is stores the value in BX at the memory location pointed to by DI using register. So register in direct addressing mode, assume DI is equals to 4000H. So first, we assume that DI is equals to 4000H. So the immediate value 4000H is loaded into DI register, and after that, we store the value. The value in BX is stored at the memory location pointed to by DI. So that's it for today's assessment, and I hope this video helps you understand the different addressing modes and how to work with them as a bit language. So that's all. Thank you for watching.